So I had a really great question from a student who was wondering, hey, what does a great claim evidence reasoning statement look like? So I thought I would take the opportunity to help us review a little bit about quantum numbers, because I know this was another question that a student had about how to use quantum numbers to figure out what the elements are. So here's a great example. Suppose you were told that for the element iron, you want to know the quantum number that corresponds to the 3d6 electron. So if you're given that element and you're given a specific electron, how do you find the quantum numbers? And because this is a claim evidence reasoning statement, we're going to need to pose our answer to the question in the form of a CER. So here's how I would approach that question. I know that based on the number 3 that I see in front, that's the third row of the periodic table, and that corresponds to my principal quantum number. So n in this case is going to equal 3. The next thing that I know is that L, my second quantum number, is always n minus 1. So in this case, because n is 3, n minus 1 means that my angular quantum momentum will be 2. Then I know that my third quantum number, m sub L, is always the values plus or minus L. And if I think about what I know about my periodic table, then I can apply that to the following. So if I have -2, -1, 0, 1, and 2, and again, this is the 3D orbital, so I have 5 orbitals, and I've filled my electrons. Remember, I always fill singly, and then I pair. So because this is the 6th electron, this is the only electron that's paired. So my m sub L in this case would have to be -2. Now, the tricky bit about m sub S is that there's really no way to know other than my 6th electron is down, right? So that's going to be a -1/2. But in reality, you would actually have to conduct an experiment to be able to know whether that electron was +1/2 or -1/2. So here's a quick recap of both my reasoning and my evidence associated with my claim. So my claim is that iron, with the electron configuration AR 3d6 4s2, has 2 valence orbitals, 4s and 3d. Because I was told that it was the 3d6 electron, the 3 in front of the d is my principal quantum number. That's a piece of evidence. That number refers to the row of the periodic table. That's my reasoning. That's how I know what I know. The second quantum number, L, is the angular momentum. It is always n minus 1. So that's a piece of evidence. In this case, my reasoning, L is equal to 2. Each number for m sub L refers to an orbital. The 6th electron is the only paired electron, so it will be -2. And I've noted that the spin can only be found experimentally, but in this case, because the electron is down, it's reasonable for me to assume that it's -1/2. So that's an example of a claim evidence reasoning statement. I have 2 more for you to think about and practice with that are like this problem. So the second one is where you're given the quantum numbers. So let's say I gave you the quantum numbers 3, 0, 0, and 1/2. So what element, electron, would this correspond to? So in this case, I know my 3 is my principal quantum number, so that's the row. It's the third row of the periodic table. That's my reasoning. The angular quantum number, L, then, is when n is -1. So L, in this case being 0, corresponds to a specific orbital, in this case, the s orbital. If you recall, L equals 0 is S, L equals 1 is P, L equals 2 is D, and L equals 3 is F. So in this case, because L is 0, that also means that m sub L has to be 0. Then, right, I'm given my spin. And in this case, I don't have a way to be able to determine whether it's plus or minus. That's something I would have to do experimentally. But what's really great about this is I know because my L is 0 and my m sub L is 0, that means that this electron, right, is either sodium or magnesium because it's in the 3s subshell. Right? So whether it's positive spin or a negative spin, I don't yet know, but I know that it's in the S subshell. I know that it's principal quantum number 3. So you could write a claim evidence reasoning statement based on that information. Hopefully this is helpful, gives you an opportunity to review quantum numbers and think about how to write a quality claim evidence reasoning statement. Thanks again.